haven't realized it, we've just developed something that is called a base changing formula. And it lets us convert every base of every logarithm into a base 10 so that we can work it. So here is like a generic form, log base b of n. Whenever we did this, if you'll notice when we looked at these examples, when it was log base 7 of 3.5, to get our answer we did log of 3.5 divided by log of 7. When it was log of base 1.5 of 22, we did log of 22 divided by log of 1.5. So if we kind of follow that same pattern here, we would want to have what on the top? Log of n divided by log of b. That is what we call the base changing formula. It takes us and it lets us take any base, no matter what it is, and convert it to a base 10 so that we can do it on our calculator. So if it asks us to use the base change property to evaluate each expression, if we have log base 8 of 32, the first thing we're going to do is we're going to rewrite it. So how would I rewrite log base 8 of 32 so that I could do it on my calculator? What would I do? Log of 32 divided by log of 8. Then you can evaluate that on your calculator just like we did a minute ago. So we've got log of 32. Make sure you close the parentheses after 32, divided by log of 8. And when you do that and you round off, you get about 1.67 if you round off to 2 decimal places. So for number 6, we have log base 7 of 1 over 49. So if we want to change that using the base changing formula, tell me how we're going to set it up. What am I going to write down? Log of 1 over 49 divided by log of 7. Now, you can do that on your calculator. So on your calculator, you're going to do log, and in that parentheses, you're going to do 1 divided by 49, and make sure you close the parentheses afterwards, and divide it by the log of 7. And what is that going to equal? Negative 2. Okay, let's try the next one. Log base 16 of 512. So what am I going to write down? Okay, log of 512 divided by log of 16. So if I'm going to do that, log of 512 divided by log of 16 is going to give me what as my answer? 2.25. Okay? So really quickly, just type in on your calculator and see if you can convert the last one and write it as a decimal.
Negative 2.5.
Thank you. Negative 2.5. And you would have typed in log of 0.03125 divided by log of 4 on that one. So everybody should be able to solve a logarithmic equation by taking a log on both sides. Everybody should be able to use the change of base property. So let's flip over to the last page of your notes. Now we're going to just take some that are in a generic form and we're going to write those in terms of a common log or using the base changing property. So if you see log base k of 2, how am I going to write that using the change of base property? What's that going to be? Log of 2 divided by log of k. It doesn't matter if there's variables in the argument of the logarithm as long as you're rewriting it using the property appropriately. So log base 4 of x, how are we going to rewrite that? Log of x divided by log of 4. If we wanted to write log base 8 of x plus 6, then how could we rewrite that? Log of x plus 6 divided by log of a. What if you had log base x plus 2 of 1/2? What would I rewrite there? Log of 1/2 divided by log of x plus 2. What this does for us, it's allowing us to change anything into that base change formula. And by doing that, it's going to allow us to sketch the graphs using our calculator. When we had logarithmic graphs earlier that we wanted to graph, we had to rewrite them in their exponential form, we had to switch the x and the y's, we had to plug them into our calculator, and then we had to switch back in the table, and it would get confusing. But by using the base change property, we're able to go ahead and graph a logarithmic function. So let's go through that process. Let's say that I wanted you to graph, for example, log base 2 of x. If we want to graph log base 2 of x, will our calculator on its own do a log base 2? No. Can we make it do log base 2? Yes, because we can use the base change formula. So what you would do is you would change log base 2 of x into something that looks like this. F of x equals log of x divided by log of 2. So go to your y equals on your calculator, and you're going to type that in. Log x, close the parentheses after the x, divided by log of 2. Close the parentheses after the 2. And then press graph. And you should get a graph that looks something like that one there. So before, we couldn't graph log base 2 of x on our calculator because we didn't know how to change the base into a common log. Now that we know how to change the base, we're going to be able to graph all of these on our calculator. So let's look at example number 13 here. It says use that strategy to sketch the graph. So the first thing we want to do is we want to rewrite it in a base that we can plug into our calculator. So we want to say f of x is going to equal, what are we going to put on the top? Log of x plus 4, and divide it by what? Log of 2. Okay? So once you've rewritten it into common logs, you are going to go to your y equals on your calculator, and you're going to just type that in. So you're going to say log of x plus 4 and divide it by log of 2. Make sure you close the parentheses after the x plus 4 and press graph. And it looks like it stops there, but that's just because our calculator will not do a vertical line. So what we're going to have to do is think about that that's really going to move the asymptote over. And you can come up with some exact points by using your table function. So when x is negative 2, y is 1. When x was negative 3, y was 0. When x was 0, y was 2. And so this function is going to look like that. So now you're going to be able to use your calculator to sketch the graphs of these types of functions. Okay, I'm going to have to change over one more time to finish up. Okay, while that